To determine the maximum amperage the panel will reach after adding the new circuits, especially the 50 amp hot tub, we need to understand some fundamental principles of electrical load calculation. In general, you can't simply add up the breaker sizes to determine the total load on a panel. This is because not all circuits will be operating at their maximum load simultaneously. However, the hot tub circuit is a significant load, and its impact needs to be carefully considered. The existing panel is rated for 100 amps. This means that the main breaker is designed to trip if the total current drawn exceeds 100 amps for a sustained period. Adding a 50 amp hot tub circuit does not necessarily mean the panel will now require a 150 amp service. Electrical codes, such as the National Electrical Code or NEC, provide guidelines for calculating the load on a service panel. These calculations take into account demand factors and diversity factors, which recognize that not all loads will be operating at their full capacity at the same time. Firstly, determine the existing load on the panel. This can be done by performing a load calculation as outlined in Article 220 of the NEC. This involves adding up the continuous and non-continuous loads connected to the panel. Continuous loads are those that are expected to operate for 3 hours or more at a time, such as lighting and heating. Non-continuous loads are those that operate for less than 3 hours, such as small appliances and power tools. Secondly, after calculating the existing load, add the load of the new circuits. The hot tub is considered a continuous load, so its full 50 amp load must be added to the existing load. Other new circuits should be calculated similarly, considering whether they are continuous or non-continuous. Thirdly, apply demand factors. Demand factors allow you to reduce the calculated load based on the type and number of loads. For example, the NEC allows for demand factors to be applied to dwelling unit loads, such as general lighting and appliance circuits. Consult the NEC for specific demand factors applicable to different types of loads. To clarify, the hot tub's 50 amp circuit will add directly to the calculated load. If the existing load calculation plus the 50 amp hot tub load exceeds 100 amps, the service is overloaded. To add this, determine the total connected load. This is the sum of all the loads connected to the panel, including the hot tub. Next, calculate the demand load. This is the load that the panel is expected to draw at any given time, taking into account demand factors. The NEC provides tables and guidelines for calculating demand factors for different types of loads. Now, check if the demand load exceeds the panel rating. If the demand load exceeds 100 amps, the panel is overloaded. If the demand load is less than 100 amps, the panel is not overloaded. Here's a more detailed example. Suppose the existing load calculation, without the hot tub, is 75 amps. Adding the 50 amp hot tub circuit brings the total calculated load to 125 amps. In this case, the panel is overloaded. However, it's important to remember that this is just an example, and the actual load calculation may vary depending on the specific loads connected to the panel. In some cases, it may be possible to reduce the load in the panel by using energy-efficient appliances or by staggering the use of different loads. For example, you could install a smaller hot tub or use a timer to prevent the hot tub from operating during peak hours. If it's not possible to reduce the load in the panel, the service will need to be upgraded to a higher amperage. This will involve replacing the main breaker, the panel itself, and the wiring from the utility company. It's important to consult with a qualified electrician to determine the best course of action. To estimate the panel's maximum amperage with the new circuits, you must perform a thorough load calculation according to the NEC. This involves the following steps. Firstly, list all the existing circuits and their corresponding loads. For lighting circuits, determine the wattage of the fixtures and divide by the voltage, usually 120 volts, to find the amperage. For appliance circuits, use the nameplate rating of the appliance in watts or volt amps and divide by the voltage to find the amperage. For motor circuits, use the motor's horsepower rating and the appropriate NEC tables to determine the full load amperage. Secondly, classify the loads as continuous or non-continuous. Continuous loads are those that are expected to operate for 3 hours or more at a time. Non-continuous loads are those that operate for less than 3 hours. Thirdly, apply demand factors to the non-continuous loads. The NEC provides tables and guidelines for determining the appropriate demand factors for different types of loads. For example, the demand factor for general lighting in a dwelling unit is 100% for the first 3000 volt amps and 35% for the remaining volt amps. Fourthly, add up all the continuous loads and the demand factor non-continuous loads to get the total calculated load. Fifthly, add the load of the new circuits, including the 50 amp hot tub circuit. The hot tub circuit is considered a continuous load, so its full 50 amp load must be added to the total calculated load. Sixthly, compare the total calculated load to the panel's rating. If the total calculated load is greater than the panel's rating, the panel is overloaded. If the total calculated load is less than the panel's rating, the panel is not overloaded. When adding a hot tub circuit, there are some specific considerations to keep in mind. Firstly, the hot tub circuit must be protected by a ground fault circuit interrupter or GFCI. This is to protect against electric shock. Secondly, the hot tub circuit must be wired with the correct size conductors. The size of the conductors must be based on the amperage of the circuit and the type of insulation. Thirdly, the hot tub circuit must be properly grounded. This is to provide a path for fault current to flow back to the source, which will trip the circuit breaker and prevent electric shock. To determine the maximum amperage the panel will reach, consider the existing load. Let's assume the existing load is drawing approximately 70 amps under normal conditions. This is an estimation and the exact amperage draw needs to be calculated as described above. The hot tub adds a significant 50 amps, but hot tubs don't typically run continuously at their maximum amperage. They cycle on and off to maintain the water temperature. So, while the breaker is rated for 50 amps, the actual average draw might be lower. Furthermore, the other two circuits being added also contribute to the load. Depending on what these circuits are used for, they could add anywhere from a few amps to a significant amount. Without knowing the exact nature of these circuits, it's difficult to provide a precise estimate. However, let's assume they add another 10 amps combined. Adding these estimates together gives a total of 70 amps plus 50 amps plus 10 amps equals 130 amps. Based on this estimate, the panel could potentially draw up to 130 amps. Given that the panel is only rated for 100 amps, this would exceed the panel's capacity. It is critical to conduct a thorough load calculation as per the NEC before making any changes to the electrical system. This calculation will take into account all of the factors mentioned above and provide a more accurate estimate of the panel's maximum amperage. If the load calculation confirms that the panel is overloaded, the service will need to be upgraded. To accurately determine the maximum amperage draw with the added circuits, it is necessary to perform a detailed load calculation, considering both continuous and non-continuous loads, and applying appropriate demand factors as permitted by the NEC. Based solely on the fact that a 50 amp hot tub is being added to an existing almost full 100 amp panel, with 2 additional circuits also being installed, the amperage draw will exceed the maximum amperage.